Bismillahirrahmanirrahim. Assalamu alaikum. Today we started a new unit, that is unit number 3, Logarithm, from class 9 mathematics book. Among different branches of mathematics, logarithm is one of the most important branch, which is widely used in other branches of science like chemistry, physics and economics, etc. The question is that why we use logarithm? We use logarithm because the basic use of logarithm is to convert lengthy operations of multiplication and division into simple operation of addition and subtraction. In this unit, we shall learn the concept of scientific notation, concept of logarithm, difference between common and natural logarithm, concept of anti-logarithm, laws of logarithm and application of logarithm. Today's topic is scientific notation. Scientific notation is a special form of writing a very large number or very small numbers very conveniently with the help of scientific notation. Scientific notation of any number is represented as a product of two numbers. First number lies between 1 and 10, while the second one is a sum integral power of 10. For example, if we have any number x, so if we want to write this in a scientific notation, so x is equal to a multiplied 10 power m. So look at, there are two parts. The first part, that is a, while a is from 1 to 10, is from between 1 and 10, while m is an integer, and you know that integer belongs positive numbers and negative numbers. So any number x, so it has two parts. The first part is a is between 1 and 10, while m belongs to integers. For example, if we have a number 7800, so it can be written in a scientific notation as 7.8 multiplied 10 power 3. Later on we discuss that how to write a number in a scientific notation, but we are here just explaining that 7800 represent x, while 7.8 this represent a, and this 3 represent m. So look at 7.8, it is from 1 to 10 or between 1 to 10, and this 3 belongs to integer. For example, we have another number 0.00729. So its scientific notation is 7.29 multiplied 10 power minus 3. Now the 0.00729 it represent x, 7.29 it represent a, while this minus 3 represent integer. Now how to write a number in a scientific notation? So before that we discuss what is meant by reference position. Reference position, it is the place between the first non-zero digit. Non-zero digit means the number which is other than 0, and its next digit on the left side of a given number is called the reference position. and it is represented by this head symbol. For example, 7,800. So our reference position is between 7 and 8 because 7 is the first non-zero digit while next digit on the left is 8. So our reference position is between 7 and 8. So we represent like that one. Look at another example, 0.00729. So our reference position is between 7 and 2 because 7 is the first non-zero digit while its next digit on the left is 2. So our reference position is between 7 and 2. So that is reference position. So reference position play a very important role when we writing a number in a scientific notation. To write a number in a scientific notation, so we have two cases. First case, if we have a number which is greater than 1. So to write a scientific notation which are of the form x is greater than 1, so we remember these points. First of all, mark the reference position. So we will mark the reference position, and you know that what is meant by reference position. For example, if we have that number 7,800, so our reference position is between 7 and 8 because 7 is the first non-zero digit and 8 is the next on the left. Then they say that count the number of digits between the original and the new decimal point. What is meant by new decimal point? New decimal point means the position of the reference position is the new place of our decimal point, while the original place is maybe on the last or maybe in the middle. So count the number of digits between the original and the new decimal point. So look at, if our decimal point is between 7 and 8, so that is our new position of decimal point, and this one, so if we count the digits of 1, 2, 3, so there are 3 digits between the new position of decimal and the original position of decimal. So write the number of digits as a power of 10. So we write this as a power of 10. So look at 7,800, reference position is between 7 and 8. So that is our new decimal point, position of new decimal point, and the original. So when we count these numbers, so digits, so these are 3 digits, so we write this as a power of 10 and we put points, so 7.8 multiplied 10 power 3. So that is the scientific notation of a number which is greater than 1. Look at 7,800, of course this is greater than 1. Exercise 3.1. Write each number in scientific notation. So these questions are related with case 1, which is greater than 1. So look at, we have a number 405000. So the required is scientific notation. So solution, we take the number, if there is no decimal point, then we put decimal point at the last. So first of all, we what will be our reference position? So our reference position is between 4 and 0 because 4 is the first non-zero digit and its next on the left is 0. So that is our reference position, and that will be our new position of decimal point. So write this in a scientific notation. We count the number of digits between the new position of decimal point and the original position of decimal point. So look at 1, 2, 3, 4, 5. So these are 5 digits. So we write 4.05 multiplied 10 power 5. So that is a scientific notation. Look at another part. 167000. The required is scientific notation. So look at, there is no decimal point, so we can put a decimal point in the last. Reference position will be between 1 and 6 because 1 is the first non-zero digit. and 6 is the next on the left, so that is our reference position between 1 and 6, and this is also our new position of decimal point. So if we count the number of digits between the new position of decimal and the original position of decimal, so these are 1, 2, 3, 4, 5 and 6, so these are 6 digits, so the scientific notation will be 1.67 multiplied 10 power 6. So that is a scientific notation. Next part, look at this is a very huge number, a big number. So scientific notation. So we put point in the last because there is a no decimal point. So we put decimal point at the last. So first of all, reference position. Reference position is between 2 and 3 because 2 is the first non-zero digit and 3 is the next on the left. So that is the reference position between 2 and 3, and this is also our new position of decimal point as well. So if we count the number of digits between the new position of decimal point and the original position, which is in the last, so these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are 11 digits. So the scientific notation 2.346 multiplied 10 power 11. And look at this is represent x. This whole number 2.346 that represent a. So look at it is from between 1 and 10, and 11 represent m, while it belongs to an integer.